Okay, so these are the review problems at the end of chapter 1 in chemistry, and I will only be working problems from the review questions, so we'll actually be starting with question number 7. And in question number 7, you are asked to say how many significant figures are in the following measurements. So for A, we have 1.06 times 10 to the 4th milliliters. So if we look at our rules of significant figures, the 1 and the 6 are significant because they are non-zero numbers. And then the 0 is significant because it is between two significant numbers. So the answer for 7A is 3 significant figures. Okay, 7B, the number is 12,000 centimeters. So our decimal place would be here. So based on the rules of, for significant figures, these two would be significant because they are non-zero numbers. And that's it. So there's only 2 significant figures. These zeros are not significant because they are not after the decimal place, and they also are not between 2 other significant figures. Okay, then for C, we have 0.0340 kilograms. Okay, so we'll start first of all with the non-zero numbers. So there's 2 significant figures. And then we know a 0 is significant if it's to the right of the decimal place and at the end of the number. So that one is significant. This one is not significant because it is to the right of the decimal place, but it's not at the end. And it's also not between 2 significant figures because that one also is not significant. So for C, 7C, we have 3 significant figures. And then for 7D, 1.0 times 10 to the 1 inches. So the 1 is significant because it's not a 0, and this is significant because it is to the right of the decimal place and at the end of the number. So with that, one has 2 significant figures. Okay, then the next question we will do is number 11. Because 8, 9, and 10 are not mathematical problems. So a carpet layer measures a room, and the room is 4.6 meters long. So it's 4.6 meters by 3.2 meters wide. And he multiplies the 2 measurements together, and he reports that the area of the room, so area is length times width, he reports the area of the room as being 14.72. And then the question says, what 2 things are wrong with his answer? So the first thing that is wrong with the answer is it has no units on it connected to it. So when you multiply meters times meters, you get meters squared. So that's the first thing that is incorrect about the answer. And then the second thing is the significant figure. So this has 2 significant figures. This has 2 significant figures. When you multiply 2 numbers together, the answer is reported to the least number of significant figures. So they're both 2. So the answer can only be reported to 2 significant figures. So with rounding, the answer would be 15 meters squared. Okay, the number 12 is a subtraction problem, 21.0234 minus 12 grams. Okay, so if we just do the math, so we would subtract 2 from this, and we would get 9.0234 grams. But that's not our answer, because when you add or subtract, you can report the answer to the number of the least precise of the two numbers in terms of significant figures. So adding and subtracting, you look at place value. So this goes out to the tenths, hundredths, thousandths, 10,000ths, but this answer only goes out to the ones place. So our answer can only be reported out to the ones place, and therefore the answer is 9 grams. Okay, next we will do number 13. And question number 13 says a US dime has a diameter of 17.9 millimeters. And the question is, what is the diameter in meters? Okay, so we're going to use the factor label method for converting units. So we put the number that we want to convert over 1, and then we're going to multiply that so that the number that we want, the unit that we want to end up with will go on the bottom, and the other unit will go, go on top, and the other unit will go on the bottom. So we know that there are 1,000 millimeters in 1 meter. So we'll multiply across the top and divide by the bottom. Millimeters divided by millimeters, our units will cancel. So it's 17.9 divided by 1,000, which will give us 0.0179 meters. And if we look at significant figures, we were dividing, so we look at the least number of significant figures. So this number has 3, so we're looking at 3 significant figures. So all 3 of these are significant. The 0 is not significant, so we have our 3 significant figures. So that would be the correct answer there. Okay, next we'll do number 14. A soup can has a mass of 490 grams. What is its mass in kilograms? So again, the quantity that we want to convert, we put that over 1, and we're going to multiply that times, put the unit that we want to end up with on the bottom and the other unit on the top, and we know that 1 kilogram is equal to 1,000 grams. So again, grams on bottom, grams on top, those cancel. So 490 divided by 1,000, and you will get 0.49 kilograms. Okay, so then we look at our significant figures. So this number has 2 significant figures. The 2 non-zero numbers are significant. The 0 is not significant because it's not to the right of the decimal place. So we can that has 2 significant figures. So our answer needs to be reported in to 2 significant figures, and we need to make sure that we include units in our answer. Okay, number 15. The volume of a soccer ball is 6,080 milliliters. And we want to know how many kiloliters that is. So we can actually do this with a two-step conversion. So the number that we want to convert, we put over 1. And then we know that 1 liter is equal to 1,000 milliliters. So the milliliters are going to cancel. And then we know that we want to end up with 1 kiloliter. So we'll put that on the top. 1 kiloliter is equal to 1,000 liters. Okay, so liters are going to cancel there, and we're left with our units, kiloliters. So we multiply across the top. 6080 times 1 divided by 1,000 and divide by 1,000, and you will get 0.00608 kiloliters. And if we look at our answer here, the 6 and the 8 are significant. And this 0 would be significant because it's between two significant figures. So we can have 3 significant figures. So this answer would be fine. The first 2 zeros are not significant. The 6 and the 8 are significant because they're non-zeros. And this 0 is significant because it's between two significant figures. If you wanted to, you could also express this as this 6.08 times 10 to the -3 kiloliters. Other answer is fine. Okay, number 16. An object has a length of 15 inches, 15.0 inches. And we want to know what its length is in meters. And we are told that 1 inch is equal to 2.54 centimeters. So again, this is it's going to be a two-step conversion. So we'll put the number that we want to convert over 1, and then we know that there are 2.54 centimeters per inch. Okay, so that gets rid of the inches, but now we're in centimeters and we want to be in meters. So we'll put meters on top, and we know that there are 100 centimeters in a meter. So centimeters cancel. When we multiply across the top, the units that we want to end up with are on the top. So 15 times 2.54 divided by 100. And that will give us 0.381 meters, because this is the number we would look at for significant figures. 1, 2, 3 significant figures. Okay, then number 17 has multiple parts, and we are converting these numbers into scientific notation. Okay, so remember with scientific notation, we want to have one number before the decimal place. So first of all, let's look at significant figures. So none of these zeros are significant, but these numbers are all significant. So we have 4 significant figures. So we're going to put 1.214 times 10 to the what? So we have to, if there are decimal places here, we have to move it 1, 2, 3, 4 places to the right. So it would be times 10, since we moved the decimal place to the right, times 10 to the negative 4 kilograms. So that's 17A. 17B is 34,500 meters. Okay, so our decimal place is here. Decimal place is right there. So if we look at significant figures, only the non-zero numbers are significant. So we can have 3 significant figures. So 3.45 times 10 to the, now we're going to move the decimal place to the left, so our exponent will be positive. 1, 2, 3, 4. 3.45 times 10 to the 4th meters. Okay, C is 123,500,000 milligrams. Okay, so decimal places here. So none of these zeros are going to be significant because they're not after the zero. I mean, they're not after the decimal place, and they're not between 2 significant figures. So our significant figures are just the non-zero numbers. So 1, 2, 3, 4 significant figures. So 1.235, that gives us our 4 significant figures, times 10 to the, how many places do we have to move the decimal place? 1, 2, 3, 4, 5, 6, 7, 8, times 10 to the 8, and we need to make sure that we put our units there, times 10 to the 8th milligrams. Okay, and then 7D, 0.01010 kilogram or kilometers. Okay, so if we look at significant figures, the non-zeros are significant, so there's 1, 2. This 0 is significant because it's to the right of the decimal place and at the end. And this one is also significant because it's between 2 significant figures. So we have 4 significant figures. So 1.010, there's our 4 significant figures, times 10 to the, we're going to move the decimal place to the right, so our exponent will be negative. So we'll move the decimal place 1, 2 places, so times 10 to the negative 2 kilometers or kilometers. Okay, so that is number 17. And number 18, convert the following measurements into decimal notation. So 1.2 times 10 to the negative 2 kilometers. Okay, so start by looking at significant figures. That has 2 significant figures, so our answer can only have 2 significant figures. So since it's a negative 2 exponent, we are going to move our decimal place 2 places to the left. So that would be 1 place. This would be 2 places to the left. So it's going to be 0.012 kilometers. And we have our 2 significant figures in that answer. 18B is 7.82 times 10 to the 7th milliliters. Okay, so we first look here and we see that this has 3 significant figures, so our answer can have 3 significant figures. So 7, 8, 2, and then from this point we're going to move the decimal place 7 places. So it's here, starting here. We're going to move it 1, 2, 3, 4, 5, 6, 7. So the decimal place would go right there. So it we put in our commas. The answer would be 78,200,000, and we need to make sure that we write our units on there in our figures. Okay, 18C is 9.1 times 10 to the negative 8 kilograms. Okay, so this has 2 significant figures in it. So we are going to move our decimal place 8 places to the left. Okay, so it's starting here. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Let's double check that. So we started with our decimal place here. So 1, 2, 3, 4, 5, 6, 7, 8. So our decimal place goes right there. So it's 0.000000091 kilograms. And we have only 2 significant figures in that answer. Okay, then lastly, D is 8.912 times 10 to the 6 meters. Okay, so this number has 4 significant figures in it, so we can have 4 significant figures. We're going to move the decimal place 6 places to the right. So we started here, so 1, what happened there? Okay, 6 places to the right, so 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So 8, 9, 1, 2, 0, 0, 0 meters. And so 8,912,000 meters, and this answer has 4 significant figures, which we were permitted to have. Okay, number 19. A bowl has a volume of 1.1 liters. What is its volume in cubic centimeters? So I write that like this, cubic centimeters, or CC also stands for cubic centimeters. Okay, so the thing you have to remember that we learned in class from the lab that we did is that a milliliter, 1 milliliter, is equal to 1 cubic centimeter. Those are equivalent measures. So we're going to start with 1.1 liter. And the unit that we want to convert goes over the number 1. And then we know that there are 1,000 milliliters in a liter. So liters cancel, and 1.1 1.1 times 1,000 is equal to 1,100 milliliters, and we just said that a milliliter and a cubic centimeter are the same, so it would be 1,100 cubic centimeters. Two significant figures here, two significant figures in our answer. Okay, number 20. A sample of liquid has a volume of 143.6 liters. What is its volume in cubic meters? Okay, so here again we have to remember that a milliliter and a cubic centimeter are the same. So if we can get those liters into milliliters, and then from that point get it into cubic meters. So 143.6 liters, there are 1,000 milliliters in a liter. The liters are going to cancel, and so this answer would be 143,600 milliliters, or cubic centimeters, centimeters cubed. So 143,600 centimeters cubed. Okay, and we want to get it into meters cubed. So we know, so this is going to take it's going to be a 3-step conversion to get to cubic meters. 1 meter is 100 centimeters. So it's going to get rid of one of those centimeters. We still have 2 more to get rid of. So 1 meter is 100 centimeters. That gets rid of the second one. So now we're down to just 1 more to get rid of. So 1 meter is 100 centimeters. That gets rid of the last centimeters, and meters times meters times meters will give us cubic meters. So 143,600 divided by 100 divided by 100 divided by 100 will give us 0.1436, and our meters times meters times meters is meters cubed. And we started with 4 significant figures, and our answer has 4 significant figures. Number 21 and number 22 deal with density. So remember that density is equal to mass divided by volume. Okay, so here in question number 21, we are given density and we are given mass, and we are asked to solve for volume. Okay, so to rearrange this equation, we're going to multiply both sides times volume. So that'll cancel that out there. And we'll have volume over here. And then we need to get rid of density on that side, so we'll divide by density. Both sides by density. So that gets rid of the density on that side. So then we have that volume is equal to mass divided by density. Okay, so we are given the mass as 55.67 kilograms. And the units for density is 2.70 grams per milliliter. Okay, so mass is 55.67 kilograms. And the density that we are given is 2.70 grams per milliliter. Okay, so the first thing you should realize is that this unit is in kilograms and this one is in grams. So we have to get those into the same unit. So let's convert these kilograms to grams. There are 1,000 grams in a kilogram. So kilograms are going to cancel, we'll be left with grams. And it's 55,670 grams. Okay, 4 significant figures here, 4 significant figures there. So now volume is going to be our mass, which is 55,670 grams divided by 2.70 grams per milliliter. Okay, so if we look at, first of all, look at units. We have a gram on top and a gram on bottom, so those cancel. And remember from algebra that when you divide by something, that's the same as multiplying by the reciprocal. So if I divide by milliliters, that's the same, that's really like 1 over milliliters. So that's the same as multiplying by milliliters, which simply means that the milliliters is going to jump up on top. So the units that we're left with will be milliliters. So 55,670 divided by 2.70. What you will get for volume is 20618.51852 milliliters. Okay, then we need to look at significant figures. And we're dividing, so we have to go with the value that has the least number of significant figures. So this number has 4 significant figures. This has only 3. So we're limited to 3 significant figures. So we could write this 20600. That would give us our 3 significant figures. The 2, the 6, and the 0 that's between the two significant figures. And we got to write our units there. We could also write this as 2.06 times 10 to the 10 to the 4th milliliters. Either answer will be fine, and both have the correct number of significant figures. Okay, number 22. Again, it's a density equation, and now we are given the mass as 1.7 kilograms. And the volume is 0.164 liters. And the question says that this looks like a silver, and we are asked if it is silver, and we are given that the density of silver is 10.49 grams per milliliter. Okay, so density is equal to mass divided by volume. So again, we need to get that mass in grams. So 1.7 kilograms. There are 1,000 grams in a kilogram. That over 1 kilograms are going to cancel, so that the mass is 1,700 grams, 1,700 grams. Two significant figures. So it's going to be 1,700 grams divided by the volume. So we need to change that volume to milliliters. So 0.164 liters. Put that number over 1. And we know that there are 1,000 milliliters per liter. Okay, so liters are going to cancel. So we're multiplying 1,000 is like moving the decimal place 3 places to the right. So the volume will be 164 milliliters. Okay, so the mass was 1,700 grams and the volume is 164 milliliters. And if we do that math, what you will get is that you will get 10.37. The units are grams over milliliters, grams per milliliter. Okay, and we're comparing that number. So this is our calculated number. This is the number that we were given as the density of silver. Okay, so this is a case where significant figures are noticeably important. So if we look here, the 1,700 has 2 significant figures, and the 164 has 3. So that means we can only report our answer to 2 significant figures. So the significant figures would be, actually this is also a case, well, no, I guess, so this would be 1 point, to get 2 significant figures, we'd have to use scientific notation. 1.0 times 10 to the 1 grams per milliliter. And the same thing if we report this number to 2 significant figures, it's also going to be 1.0 times 10 to the 1 grams per milliliter. So if we had looked at our original numbers, we might have said they weren't the same, but they are the same because we're limited to 2 significant figures. So the sample that we had was in fact silver, had the same density as silver. Okay, so that does it for the review questions for Chemistry Chapter 1.